Hi everyone, welcome to the Digital Health Channel. We're really happy to be presenting you with this interview today. We have as a guest Sir Richard Roberts. Unfortunately, our co-interviewer Diana von Stein, she hasn't been able to attend today this interview, so it will be just me and Rick. Hi Rick, welcome.
Hi, welcome.
How are you doing? Please introduce yourself a little bit about some information about you so we can share with the audience today.
Sure. Well, I'm currently the Chief Scientific Officer at New England Biolabs, but I've had a long journey to get here. I started off in England. I grew up, well, I was born during the Second World War, and then grew up in Bath in the southwest of England, and then went to Sheffield University to study chemistry. And after that, I read a book called The Thread of Life by John Kendrew, which convinced me I wanted to be a molecular biologist. And so I switched when I did my postdoc. I went to Harvard and worked with Jack Strominger, and there I was doing molecular biology. But the key thing that happened then, I spent some time, a few weeks, in Fred Sanger's lab at the MRC in Cambridge and learned how to sequence RNA. And I got interested in sequencing and what was in the sequence of RNA and DNA and so on. And then got a job at Cold Spring Harbor Laboratory. And there started working on restriction enzymes. Among other things, we discovered some 70 of the first 100 restriction enzymes known. And these turned out to be, well, among other things, the basis of the company that I now work for. But along the way, we started to use these for some interesting projects. And getting back to my interest in sequencing, we decided to look and see if promoter sequences, the sequences in DNA that tell the RNA polymerase where to start making RNA, i.e. at the start of a gene. And we discovered something rather interesting, that the genes in eukaryotes, in all higher organisms, were arranged somewhat differently from those in bacteria. In fact, they were split into pieces, into introns and exons, and that work was accomplished in 1977, and I later won the Nobel Prize for that discovery in 1993. I continued working at Cold Spring Harbor until 1992, and then moved to New England Biolabs, the company I'm now at, and which I had helped get started back in 1975. And at the moment, my work is involved in studying DNA sequences, but in particular, studying DNA methylation and DNA methylases in bacteria. And that is turning out to be extremely interesting. It's an area that I love because there are not a lot of people working in it, and there are many discoveries to be made. So some of these methylases, we know why they're there and what they do, but for many, we have no idea why they're there or what they do. And so biologically, there are some very interesting questions to ask.
Thank you so much, and really interesting fields that we are going to be speaking a little bit more deeper in as we go in this interview. I don't know if you know, but before I decided to become a medical doctor, I actually applied to genetics, genetic engineering at the University of San Marcos, where I am actually, funny enough, faculty of nowadays, and eventually it became medicine. But it was a field that I also was very passionate about, especially when we met each other some years ago or many years ago.
A long time ago, yes.
A long time ago. It's been such a long road. So Rick, before we continue, I've heard a couple of interviews that you've made before at different universities, and one of the things that I really like is the story that you always tell about how you wanted to become a detective, and that feeling of wanting to become a detective took you through life sciences and until the moment where you became a scientist and in the field that you eventually really went deep into. So do you want to tell us a little bit today, what's that story about being a detective?
Sure. Well, ever since I was pretty young, I used to read a lot of books. And when I was about, I don't know, 8 or 9, I read a book called How I Became a Detective. And it was a regular detective, and it sounded fascinating. because at the time, the one thing that I liked more than anything else was solving puzzles. I love puzzles, mathematical puzzles, word puzzles, anything. And so being a detective sounded as though I could make a career out of solving puzzles. And so from then on, I really wanted to become a detective. But then my father bought me a chemistry set, and I discovered there was a lot of fun to be had in chemistry. You could make fireworks and all sorts of things that could explode, and that was kind of fun too. And so that took me to chemistry. But now, when I look at where I've reached doing research, research is really about being a detective. It's just not the regular sort of detective. It's about finding answers to different sorts of puzzles. And it's lovely. I feel that my current job, I've really embraced all of the passions that I've had through life. I love mathematics, I love puzzles, wanted to be a detective, wanted to do chemistry, and now I'm a molecular biologist, looking at a computer all day, trying to solve problems in DNA, and really being a detective all over again.
That's an incredible response, and I love the fact that you said I'm actually being a detective while you are working in the field of life sciences. Um, I think many of us have these types of dreams when we were kids, and eventually we realize sometimes that we didn't really accomplish them. But on the other hand, we kind of do, just in a different field, and that's something that really makes a person happy when to hear that you're accomplishing to being a detective in your field. So let's go now to the part of innovation, because we're talking about innovation today. And if there's not who else to ask for an innovative perspective than a Nobel Prize laureate? So how would you describe your relationship with innovation? How do you innovate, let's say in your day-to-day life or in your professional life, and what are the benefits that you consider from an innovative mind in the field where we are in life sciences?
Well, I think, a lot of innovation is just imagination and being creative. And so what I do research. I don't know where it's going to take me. I start asking questions. I start looking to see how things work. And sometimes when you find the answer, you discover that there are ways in which that answer can be used in ways that you hadn't expected ahead of time. So I don't really go looking for something that's going to be innovative. But when I make discoveries, I always look to see, well, could that lead to something new, something that people haven't thought about before? And I think one of my biggest characteristics that has also caused a lot of problems for people is that I hate people telling me what to do. I always feel it must be rather boring if they thought of it. And so I like to think of new things for myself, and I like to do things that people haven't thought of. Or in particular, I also like doing things that people tell me I shouldn't do. That always seems to me rather interesting, that if there's some reason not to do it, or they found a reason not to do it, perhaps that's a good reason why I should do it. And so my wife will call me contrary. I don't like to do things that she or other people want me to do. Doesn't always endear me to her.
Well, you know what? This is, I think this is the common denominator for a lot of people that are in the innovative space. I'm also really bad at with, I mean, from the beginning of medical school, I was really bad with authority. I really didn't like people to tell me what to do. And nowadays we are in the part of like developing solutions, right? And in the case of us in the digital space, and we are also being told constantly by many different parties why what we are thinking of is not going to work. And that's exactly why we work on it better and with much more attention, because we just want to demonstrate that actually our hypothesis is correctly. So, but that's part of the scientific method. It's part of research. And I really really enjoy to hear your response, because this is, I think, something that many of the people that are watching today, we have a lot of people on LinkedIn connected and watching this live. They probably are thinking on the same thing. This is how I am, and that really bonds us all together. So let's continue now to the part of where you were speaking before about the discovery of the introns and the mechanism of gene splicing that eventually led to your Nobel Prize. So we would like to maybe emphasize in this, and for the people that are hearing that work in life sciences, they probably are very fascinated with this topic. What are the applications that you see that these discoveries have originated, so that have already happened? And of course, how do you see the future of technologies such as mRNA and other genetic applications?
Well, one could talk for an hour about that if one wasn't careful. Um, I think there are a couple of things that I really like to emphasize about the discovery itself. One is that it was really a discovery that followed failure. And I always think failure is actually a good thing because when you fail at an experiment, either nature is trying to tell you something that things don't work the way you thought they did, or you just screwed up in some way. And I always like the idea that it's nature trying to tell me something. And then the other lesson that comes from that is chance. I was incredibly lucky. I wasn't looking to discover splicing and introns and exons. They just came along by chance. And I think most people who win Nobel Prizes will tell you that the discoveries they made also came by chance. It wasn't that they were looking for this discovery, because all of the great discoveries, no one had thought about them before. And so that is always very nice. Now, we made the discovery in 1977, and while everybody immediately realized that it was important that if we were going to really try to understand how eukaryotes and humans and so on worked, we had to know about this. We had to know that this was the way that the genetic information was being used. And so, really, the first uses that came from this were in trying to interpret DNA sequence. So, for instance, when we got the human genome sequence, had we not known about introns and exons, it would have been indecipherable. We would not have been able to make any sense of it. And prior to that, we had sequences for many other eukaryotes. And again, the only way in which we could make sense of them and understand at least a little something about how they were working was a knowledge of introns and exons. And everybody always thinks that, well, you make a big discovery, and so there are going to be all sorts of good things coming immediately. And I think anything that is connected with medicine, you often think, oh, there must be medical implications for this. And so there are going to be some new cures or something else new coming along. But in fact, it wasn't until about 3 years ago that there was a medical application of this discovery. And this was a way of treating spinal muscular atrophy, which is caused by a defect in RNA splicing, in this method of making sense from introns and exons. And the discovery of how to fix that was actually made by an ex-postdoc of mine. And so I was particularly pleased that, he'd worked with me. He was really good as a postdoc, and he went on and made this terrific discovery and figured out that you could, in fact, solve spinal muscular atrophy by altering the splicing so that it now happened correctly instead of incorrectly. Now, that's a fairly rare kind of thing. There are not a huge number of diseases we know about that are caused by alternative splicing that you might be able to fix. There are certainly some. But I think the more exciting possibility is to be able to do genetic engineering at some point in the future so that you actually fix the DNA so that this improper splicing doesn't take place. Now, of course, the other great discoveries that have been coming recently relate to messenger RNA, the products of RNA splicing. And messenger RNA has turned out to be a wonderful way to make vaccines. And I think anybody who has been even marginally looking at the news or reading the scientific literature or the medical literature will understand that the vaccine against COVID, the two vaccines that are most effective, the ones from Pfizer and Moderna, are based on mRNA. And so you basically use the mRNA in order to drive the production of the protein, a surface protein on the virus, and then that will elicit antibodies that will help stop the disease. And so this has been a really wonderful way to make a vaccine. It came incredibly quickly. the method itself lends itself to change rather easily. So if we do in fact come across variants that are completely resistant to the vaccine, then we could in fact make another vaccine fairly quickly, probably within a couple of months, and then start testing it to see if it's effective. But I think there's every reason to think it will be effective based upon the previous COVID history. And of course, we can do that for other diseases too. And so I think this is going to herald a whole new approach, a whole new way of thinking about how to make vaccines against some of the very common diseases out there, like flu, tuberculosis, malaria, and other things, all of which one could imagine treating using mRNA vaccines. And for me, that is really a wonderful thing. I think it's really a great example of how biotechnology, which really got started back in the early 1970s, is finally starting to bear immense fruit. We've had many discoveries since then. For instance, diabetics get human insulin as a result of biotechnology. We can improve plants using GMO techniques. And the sooner we convince the Europeans that this is a good thing, that will be really good for the developing countries. But biotechnology is so powerful and so useful and so helpful. And the vaccines have really shown everybody. I don't think there is anybody who ever witnesses the news who is not now aware that the COVID vaccines have been a tremendous leap forward. And so that's very, very, it's good, it's cool, it's terrific. Makes one's life seem worthwhile.
Yes, you just reminded me that I was having a conversation some time ago with a person that actually a professional that works in the agricultural sector, and he was telling me, the European Commission and their anti-GMO laws and what they are doing right now is they're lobbying that absolutely nothing can get enhanced within the European borders. So it has to or go somewhere else and then come back as a already made product, or and that would actually decrease the level of business that Europe can have. And he was explaining me a little bit about disease defense and growing in harder conditions, especially at the moment that where we are, where the climate change is basically affecting everything, including the soil and the availability of bioavailability of ground and water. We need to enhance several of the ways that plants grow, and it's something that definitely in the future has to be revised. I completely agree with you. it's
Well,
it's a
it's
pity.
something we need to do quickly, because there are
Yes.
ways in which improved agriculture can combat climate change. And that can be useful too, reducing the amount of CO2 going up into the atmosphere, picking CO2 up out of the atmosphere and converting it into trees or into other things that are long lived. And for the developing world, if they don't get access to GMO foods, then they're not going to be able to feed themselves. They already have trouble. And if Europe thinks it has an immigration crisis now, when the population of Africa expands even further, they're all going to be heading north where the food is. And I don't
Yeah.
think that is what the Europeans want. At least looking at what the Europeans have been doing about refugees trying to make it from Libya to Europe.
Well, this is a tough subject, and I think many of the people that are here are probably going to be agreeing with it. I mean, just by thinking of what you can really achieve when you have a higher yield per plant within agriculture, and you need less liters of water to grow the same amount of kilos of product. We're talking about something that would potentially really benefit everyone. So it's
Yep.
really interesting what you're saying. So we have reached to the 20th minute of our interview, and you have responded to many of the questions that we already have for you. I would like to ask the audience to start writing their questions on the comments so we can ask you questions before we close this interview. As I said before, and I also published it in the invitation to everyone that is here. It's a limited amount of time that you have for us, so it would be very interesting to just hear what the audience has to say. So that being said, I want to go now to the topic of mentorship. because we have a really interesting and peculiar story, you and I, um, from the moment when we met when I was only 14 years old, and the way that you have guided me through my medical career, and where we are now, where I can actually interview you in this public platform. I would like to know what is your view on mentorship, and how do you actually perform these types of supports to young generations in your day-to-day life.
Well, obviously, mentorship is very important. It takes many forms, though. It's not just a question of finding someone and teaching them. Sometimes it's just answering questions from time to time. Sometimes it's finding the right audience to talk to, and they become inspired by the words you have. But you mentioned that you were only 14 when we first met. I had a very interesting experience recently of teaching, of going and lecturing at a local school here with 11 and 12-year-olds. And I talked to them about GMOs. And they were a very attentive audience. They asking questions. We had a very good discussion. When they'd all been told by their teacher, they had to write to me afterwards to say what was their impression of my talk. So many of them wrote, I think there were 8 or 9 wrote, and they said something very interesting. They said this was the first time that they'd ever been spoken to as though they were adults. And I thought that was a little sad, actually, that teachers are talking to their kids, but not giving the kids the impression that they're growing up and that they could be adults. But probably the best comment I got back was from one young girl who wrote to me and said she'd gone back and talked to her parents about everything I'd been saying, and her parents had been very anti-GMO. And by the time she finished talking to them, they switched completely and became very pro-GMO. And so that taught me something rather interesting. I think we need to spend more time teaching our younger children about the important lessons in life, because very often their open-mindedness and their ability to think is way beyond anything that we might have expected. And we should give them every opportunity we can. The future of the world is in the hands of the youth. It is not in my hands. I'm too old. I can't make much of a difference. I'm not going to be around long enough. But you and young kids, you really can make a difference. And so I always like to say, well, it's very important that kids become activists, that you don't just listen to the rubbish that the politicians are telling you, that you start to think for yourself and you find out whatever you can, either by going to classes or by reading. And I think reading is incredibly important, and reading not just about what you do, but about other things too. So I've read a number of books that by the time I finished them, I changed my views about a lot of things. And I think it's quite interesting. I'll tell you just one story. Malcolm Gladwell writes extremely provocative books. And he talks about what you do when something bad happens. And so if it's an airline and they have a crash, then they do an incredibly in-depth study to find out why the plane crashed. And everybody tends to cooperate. The people in the airline, the pilots, and so on. Everybody wants to get to the bottom and find out what happened. But unfortunately, in the medical profession, the same thing does not happen. Doctors very often fail, but they're scared to admit it because they think they will lose the trust of their patients. And I think that is something that we need to find a better way of dealing with that, because failure is the time when you learn. If you fail and don't learn from that failure, that's really bad. And so you should always do a good post-mortem, a good inquest to find out why whatever it was you were doing failed. And that way you make progress.
Completely agree with you. Actually, I nowadays I became a patient, like a chronic patient, a couple of years ago. I suffer of an autoimmune disease, and while I've been going through my journey as a patient, I realized of sort of the behavior that we have had as doctors against patients for, even in my culture, when dealing with a patient, we make a lot of different mistakes. And one of the mistakes that we crucially make is that we blame the patients for almost everything. So when I became a patient, I realized, well, there's one thing that is not patient centric, and is my entire journey. I am not the center of this journey. The center of this journey is my doctor, and that's unfair. And I think that in this new era of patient centricity, when we are trying to create new solutions for patients, we have to really think like them and put ourselves in their position when we develop, um, just as you said, because otherwise, then we create a really unfair medical practice, and that's what it's been happening so far. And one more thing, what you said about reading, I think that miscommunication it happened during these times of COVID. If there's one thing that has shown us, is that we can't be trusting what we see on the media every day on social media. We really have to go ahead and do our research from well established sources, so that we actually get the truth. Because there have been so many different things that have been said so far, and even governments have taken some missteps. I mean, remember the AstraZeneca situation that happened in Germany. So for that, we have to do our own research, and we have to do and you have to use the scientific method. Now we have a person here in the audience that is asking for some questions. So before we go, I would like to just read the question. She says, "Are there times when you thought a particular effort of yours in research was not getting you anywhere?" She said, "Did you ever doubt your ability to discover anything? What made you keep going in those times? And did you think you were going to discover something big like this?" This is from Shivani Sabarish.
Okay, well, I think this is always a problem whenever you're doing research, that you do experiments, things don't work, you don't get the results that you wanted, or the results are not as clean as you would like them to be. And at some point, you have to ask yourself, is this a problem that I can solve? Is it even a problem that is soluble? Maybe I'm asking a question and we don't have enough basic knowledge to know if we can answer it at this time. And that becomes quite difficult. And so I think it helps if you're obstinate, which I am, if you don't like to give up on your favorite ideas once you've been pressing forward with them. And so I tend to stick to things until I realize that it really isn't going to work out. And at that point, I change. But more often than not, I change for quite different reasons. I change because I read something. I read about something that seemed to be far more interesting than what I was doing at the moment. And at that point, I have no trouble giving up on something that's not working out so well and moving on to something else. And I really encourage everybody to think the same. Just because you're heading in a particular direction doesn't mean you have to spend the rest of your life in that direction. You may be a doctor now, but perhaps you will read something and discover there are other things that are much more interesting and about which you could be even more passionate. And don't hesitate to change, because every time you change fields, you come with new questions. And the nice thing is you can ask really stupid questions, and the people say, "Oh well, he's new, he's not been here very long," and so they try to answer. And very often you find they don't know the answer to some of these stupid questions, and that can be most rewarding, very rewarding.
This is an amazing answer, by the way. Uh, just listening to it, I really enjoyed it. Well, you're completely right. I mean, I have been. I call it. We call it pivoting. We're pivoting in our careers, and I'm not afraid of it. And I think there's a lot of doctors and other people in life sciences that are really not afraid of just pivoting. Um, it has there's a generational study that I read the other day about the previous generation, that so the baby boomer generation, and then our generation, which is the millennials, and the generations that are after that. And I was reading that our generation is a generation that is not afraid of pivoting, is not afraid of changing the way they go in their careers, and they are not stigmatized by the label that they are placed on themselves when they just received a bachelor's degree. Um, And that is interesting that you say, because many people are afraid of taking a path that maybe might lead somewhere else than what they are, really meant to, according to the rest of their circle, their society. But at the end of the day, it can be the most rewarding to prove everyone wrong. Just what you just said. Uh, so
No, it's true.
it's really, it is true. It is true. So thank you, Shivani, for your question. And now we're going to be, we are at 30 minutes, and I promised you that it will be 30 minutes. I'm not going to take too long. I would like to ask you to maybe deliver a message for the medical professionals, or for the life science professionals, or any other professional that is watching this live right now. What would you tell them to take as a food for thought after this interview, and maybe you could change some of their professional lives?
Well, I think a message that I give to a lot of people is to realize, and especially for younger people, is that failure is not a bad thing. It's okay to fail. The problem comes if you fail and you somehow feel that you're not worthy, you're not worth anything because you failed. And I think rather the opposite. Failure is good, but just find out why you failed. Just do a little research, find out why this didn't work, that didn't work, why the job you're in at the moment is perhaps not the one that you're best suited for. Then you really learn from failure. And it's amazing how many people who have been incredibly successful owners of companies tried 2, 3, 4 times to start a company before they found the way that worked. And so embrace failure, make the most of it. And in particular, never, never, ever tell your kids that they're not very good because they failed. Tell them that they should go back and find out why they failed, and try not to do it the same thing a second time.
That's really great advice. I think that this is something that people that are in research and in academia have to also take with themselves. There's a lot of big numbers of people suffering of burnout in academia, and sometimes because failure, they don't take failure the way failure should be taken.
Yeah.
Like, so great message. Thank you very much for this interview, Rich. It has been an amazing 32 minutes, and we are going to probably invite you again at some point, but not too soon, because we know that you have so many other commitments. And thank you for the audience that has been today present. We have had a really record amount of audience just watching today. How you think, your mentality, and your thoughts. So without anything else, I would like to thank the audience. Thank you, Rich Roberts, for this amazing interview. And until the next time, thank you very much.
Okay, thank you, and good luck to everybody.